All right, let's kick it off. Streamlining your service mesh with Linkerd as like A, B, C, D, E, F, G. Yeah, so alphabetized, I'm first. So I'll just start with my introduction. Yeah, I'm Cedric Kaufmann. I'm, as I wrote, based in Berlin. I've been a solution architect at GiantSwarm for about 3 years and counting. I was part of the team that built the app platform, for which I'm going to give a quick intro later. And later I became part of the connectivity team, where we concern ourselves with anything related to networking in and around Kubernetes,
Nice.
AE, Linkerd.
I'm Flynn. I'm a tech evangelist for Buoyant. In a previous life, I was actually the original author of Emissary Ingress. I'm still a maintainer there. So I've been doing various things in the cloud native space for 7 years, something like that, 8 years. Feels like longer than that sometimes. But now I'm over at Buoyant teaching people about Linkerd and how to use it and all things like that. It's been a lot of fun. So we do have some slides. I don't think we have too many. We're going to do a very quick intro to Linkerd itself, quick intro to Giant Swarm. We're going to quickly walk through kind of what the demo application we're going to show off looks like, and then we will do a live demo of Linkerd adding resilience to a terrible application. And hopefully the demo gods will smile upon us as we go through and do this. So yeah, Cedric, or actually no, the intro to Linkerd is first. I can do that. Linkerd, Linkerd is a service mesh. If you're not familiar with the term service mesh, it's an infrastructure layer providing security, reliability, and observability down at the platform level across your entire application uniformly without requiring you to change anything about your application. This makes it very easy to let your application developers worry about the application and then have a separate group of people worrying about the integrity of the platform. It gives you a nice way to separate these two concerns and allow both of those teams to work very efficiently without constantly stepping on each other's toes all the time. As far as how it works, you can go ahead to the next slide, please. Most meshes, including Linkerd, make all of this stuff happen by actually injecting tiny little user space proxies next to each application pod in your application. This is collectively, we refer to those as the data plane. And next point there, there's also a control plane that kind of sits off to the side and does things. The control plane is basically responsible for managing all the proxies. But if you look at these proxies and where they are, since they actually take over connectivity between your applications pods, this makes the service mesh be in an ideal place for mediating communications and also monitoring and measuring everything. It's an exceptionally powerful tool because it has exceptionally broad low-level access. Another nice point about Linkerd is it doesn't really care what kind of cluster it's working on. So it tends to work equally well on almost every kind of cluster you can throw at it, from K3D clusters all the way up to gargantuan huge things running out on hosted cloud providers. You will have to pay attention to some security things. So Linkerd requires either an init container or a CNI plugin, and so you're going to have to worry about that. This is generally not a big problem. There are some clusters on Giant Swarm, it's pretty easy to get all this working. On some of the other ones, it's a little bit more challenging, but it can always be done. And with that, Cedric, off to you to talk about Giant Swarm.
Thank you, Flynn. I want to give you a quick overview of Linkerd's components and how they're deployed. There is a number of ways you can deploy Linkerd with. Not the least is Linkerd CLI, which makes this super simple. But naturally, I want to do this by showing off the aforementioned app platform. But for that, I have to give you a really quick overview of how managed clusters at Giant Swarm work and how the app platform does this. So let's start with the management cluster here in the middle or on the left. It is used to orchestrate the workload clusters here on the right. Basically, anything that makes up a workload cluster can be defined as a Kubernetes object on the management cluster. The app platform at its core is a fancy but robust way to deploy Helm charts on your workload cluster. With the app platform, we provide some of the most used and useful applications like Linkerd Nginx Ingress Controller, Prometheus, and obviously Linkerd as a managed app. Those are usually adapted versions of the upstream projects with a set of recommended settings and configurations that will work out of the box on any giant swarm cluster. Let's now jump into the user's perspective here. On the left, naturally, any resemblance to somebody you know is purely coincidental. There is a number of ways.
That photo reminds me of somebody, but I can't quite put my finger on who. Yeah.
There's a number of ways to interact with the management cluster. There is a graphical user interface called Hapa. We won't really get into that one, but I can kind of show it off at the end of the presentation if you want to. As this is a normal Kubernetes cluster, you can also just use the Kubernetes API with kubectl. Lately, we've also been started using GitOps approaches to manage clusters and their configurations. So here I will keep it short and do this through kubectl in the demo. For configuration purposes, a workload cluster is represented as a namespace on the management cluster. That's what we have here. So let's say our workload cluster's name is Donkey. Now we have a namespace, Donkey, on the management cluster. Now we employ a CR called app, which is deployed to the management cluster and defines as itself a managed app. In this case, it's Linkerd CNI.
I'm sorry, that app CR is something defined by Giant Swarm, right?
Yeah, so that's a custom resource that's provided by us and the app platform.
Thank you.
Right. So this at its core is still a Helm chart. So we can supply configuration via a YAML file, commonly known as the values YAML. The config file can be specified as a config map and or a secret. In case of secret, it's kind of for the more sensible type of information. In the case of Linkerd, we usually supply the certificates used to mesh the workloads through the secret. So now we told the management cluster to make sure the app Linkerd CNI is deployed on the workload cluster Donkey. And next we actually see the chart for this is also a custom resource that we supply with the app platform, which is called charts. And it's basically a copy of the Helm chart with its related configurations, again, as config map or secret. All right. Let's jump over to Donkey and talk about how the service mesh Linkerd is deployed to a Kubernetes cluster. So that's your common Kubernetes cluster. So before we deploy the Linkerd CNI, which is actually just a daemon set, and now as such, it will run an instance of Linkerd CNI on each node, which gives Linkerd the ability to change the cluster's underlying container network, which is utilized to mesh the different workloads, again, in a correspondence with the proxy on the user space that is implemented. So there we see Linkerd CNI running on all the nodes. Next, we can, similarly to the Linkerd CNI, deploy a Linkerd control plane as an app. This will monitor specified resources for an indication that the deployment related resources should be meshed, and then does so by injecting the user space proxy. So enough for the boring stuff. Let's do demo time.
One quick question for you.
Sure.
You mentioned the Linkerd CNI. Linkerd can also work with an init container that reconfigures the network. Does Giant Swarm support that, or is it always the CNI?
We do support it. We recommend the CNI approach for obvious reasons. But yeah, the actual control plane, so Linkerd control plane app also basically supports any configuration that the upstream chart would support. So obviously you can kind of just configure it to do so.
Cool. Yeah, we also generally recommend the CNI when the CNI is an option.
Right.
Okay.
I guess so. Oops.
Let me start sharing my screen. Sorry, go ahead.
Okay.
See, this is how you know we're doing it live with Cedric and I go, okay, wait, should I share? What are you?
Let's try again. So yeah, you want to quickly talk about what we're going to see?
Let me flip over and share mine.
Sure.
Hopefully this is the most complex part of doing this live. All right, everybody can see that again, right?
Yeah.
Okay, so we're going to demo all of this by actually running an application and then playing around and using Linkerd to do better things with that application. This is what our application looks like under the hood. We start with our cluster, as always. Outside the cluster, running in my web browser, we have a single page web app, which is the Faces GUI. This whole thing is the Faces demo. The Faces GUI calls into a service called Face inside our cluster. The Face service in turn talks to the Smiley service and the Color service. The Smiley service is supposed to return a smiley face. The Color service is supposed to return the color green. The Face service will then take those two, put them together, and hand it back to the GUI. The GUI has a matrix of these things, and so it will go through and call the Face service one time for each cell in the grid and constantly refresh what's going on. Under the hood, all three of these services, Face, Smiley, Color, plus a fourth service that serves the web page, those are all in their very own namespace called Faces. We have Emissary Ingress as the Ingress controller for all of this. The Ingress controller is actually kind of irrelevant for this particular demonstration, except that we have to have an Ingress controller. And then under the hood there, Linkerd, as Cedric mentioned earlier, puts its little sidecars next to everybody so that Linkerd gets to mediate all of these communications. Now, before I actually flip over and show the demo itself, I should point out, I said that the Face service is supposed to always return a smiley face. Or sorry, the Smiley service is supposed to always return a smiley face. The Color service is supposed to always return the color green. They don't actually do what they're supposed to. The Faces demo is a deliberately terrible, horrible, no good, awful application. So it fails a lot of the time in a lot of different ways. And you will see lots and lots of different things that we'll talk about as we go on. Okay, so like I said, this is a demo where we're going to talk about how to take Linkerd and make a horrible application behave better. Basically, we're going to use Linkerd, we're going to use the service mesh to add resilience to this application. We're going to look at two things in here. We're going to look at retries. So if you have a request and it fails, Linkerd can automatically retry the request for you. And we're also going to use timeouts because the various services in the Faces demo can be very, very slow. And we will see that these are really simple techniques, but especially combined, they can have a pretty large effect. So this is what the Faces demo looks like when we start off. Like I said, lots of different things that we might see here. What we're supposed to see is always this success case. If we can't talk to the Face service, we get an error from that. That's, the GUI makes the call to the first service and that breaks. We'll get this red background and a frowning face. If it could talk to that, but the color service failed, we'll get a gray background. If the smiley service fails, we'll get a cursing face. And then we can see timeouts and things like that as well. So you can see just by looking at this, that this application is really not behaving very well. On the other hand, we don't have a good way to see where the failures are happening. We don't have a good way to see how often they're really happening. And we would like to use Linkerd to help out with this. So we can flip over and take a look at the Linkerd Viz dashboard, but that shows us nothing useful because we don't actually have anything injected into the mesh yet. So that's our first job, is we have to get these applications participating in the Linkerd mesh. We're going to start that with Emissary because the browser is talking to Emissary, which in turn is talking to the Faces app. And the way we're going to do this for Emissary is we will just mark Emissary's entire namespace as any pod that shows up in this namespace. Linkerd, go ahead and put a proxy there so you can manage it. After applying that annotation, we have to restart everything. The reason for this is that Linkerd pays attention to the creation of pods. And whenever a pod shows up, no matter where it shows up, then Linkerd will see that that happens and decide whether or not it needs to go ahead and inject everything into the pod. Since the effect only happens when the pod actually gets created, we need to do a rollout restart after annotating the namespace. Now, this is the longest and most boring chunk of this particular demo because we have to wait for Emissary to restart. So if anybody has questions, now is a beautiful time to ask questions. Cedric, do you have any questions?
No, as I've seen this before. Sorry, it's super simple.
I see. No, go ahead.
Yeah, no, but how? No, that's coming later. So it doesn't make sense to ask that question yet. Sorry.
Okay. Well, while we're doing this, I'm going to flip over to the Linkerd dashboard where we can see that Emissary is showing some meshed workloads now, and we're seeing some success rate metrics and some request stats. So that's good. And okay, there we go. So I think we probably have almost everything done now for Emissary. 4 out of 5. Come on, you can do it. And here you'll notice that that success rate just dropped. That would be because we're now getting better information about calls back into the face service that are starting to fail. Well, really, that have been failing all along.
Yeah. So what's that we're currently looking at, like the UI?
This is the Linkerd. This is the Linkerd Viz dashboard. When Cedric installed Linkerd into this cluster, he also installed Linkerd Viz as an extension to Linkerd that provides visualization tools, hence the name. One of the main ones that it provides is this dashboard, which sort of gives us a quick overview at this point of all the namespaces. And we'll do a little bit more with this later. But I will point out right now that everything is meshed on the Emissary side. Our GUI is still working. This is a good sign. One of Linkerd's design goals, in fact, is that if you have a working application and you install Linkerd, it should continue to be a working application. We should not break anything by putting the mesh in place. Yeah, we just did that. So, once again, we've got all 4 of the Emissary namespaces workloads are now participating in the mesh, and we're seeing a success rate of only about 90%. Also seeing almost 10 requests per second. Mathematically, there are 16 cells on that grid, and each of them is supposed to refresh every 2 seconds. So we should see about 8 requests per second, but anything a little bit on either side of that is normal for this demo. Okay, so we're going to repeat that same process for the Faces namespace. Thankfully, this is a lot faster. So we'll mark the namespace as injectable. We'll do a rollout, restart, and then we'll just sit here and watch. And we might actually see, some more red frowning faces as these things go through and roll out. But honestly, this behaves so badly by default that it's difficult to really tell when that's happening. But if we look over here, we can now see that all 4 of the faces workloads are meshed. And we start to see, oh yeah, we've got some metrics now too. If we drop into the faces namespace itself, first thing you'll see that it actually shows us a topology graph. So we can see that, yep, the face service talks to the smiley service, the space service talks to the color service, color and smiley don't talk to each other. And we can also scroll down a little bit and we can get individual metrics for each of these deployments really easily. All of these should land right around 80% success right now because all of these workloads are actually coded to have a 20% failure rate. So it's nice to see that our demo is behaving the way we would expect it to. And again, we would expect all of these to land around 8 requests per second. It actually, right when you mesh something, it takes a little while to accumulate really good stats. So we'll probably see that change a little bit over time. So let's flip back over here. All right, so now we have our horrible application. It's running, it's in the mesh. We can use Linkerd to see things about it within the mesh. Now let's use Linkerd to change some things in the mesh. The first thing we're going to do is try to get rid of these red frowning faces. Those are the ones where our web app is actually trying, things like this. That's where the web app is trying to talk to the face service and the face service itself is breaking. So we're going to use a Linkerd service profile. Specifically, we're going to put this in the faces namespace because the workload we want to manage is in the faces namespace. We're going to give it the fully qualified name of this workload, and it must be the fully qualified name. This is one of the most obnoxious bits of a service profile. And we're going to tell this that for absolutely any GET request, we will consider it to be retriable. Generally speaking, this would be a bad idea because most real applications, there are some things that are retriable. They're idempotent requests. You don't have to pass any data in. You're always going to get the same thing when you call them. Those are great for retrying. There are a bunch of other things in real applications that are not so good for retrying. So in the real world, you need to be much more careful about what you put in the matches. In our case, we're just going to retry everything. So the other thing that's worth pointing out here is that we did not tell Linkerd how many times it was allowed to retry. The reason for that is that Linkerd has a concept of a retry budget, where it looks at the total traffic, it looks at how much of the total traffic is retries, and as long as the retries are not more than a certain percentage of the total traffic, it'll just keep retrying. By default, I believe it's 20% allowed retries, but you can configure that. So when we apply this, the red cursing faces should just vanish entirely, and we will see if that really happens. So that is now applied. I'm not seeing any red frowning faces, not red cursing faces. I'm not seeing any red frowning faces. That's a good sign. So apparently the demo gods are continuing to smile upon us. So we can repeat this for the smiley service, which will get rid of those cursing faces that show up every so often. This is exactly the same resource, except that we have to use a different fully qualified name here. When we apply those, we should now see nothing but smiley faces. That seems to be working as well. That's good. I'm happy about that. And we can do the same again for the color service, where once again, all we're changing here is just the name of the service. That should make the gray backgrounds go away and leave us nothing but green backgrounds with smiley faces over them. So all that so far so good. If we flip back over to the Viz dashboard right now, you get an interesting thing where you'll see that these success rates are still showing you those 80% numbers. The reason for this is that the purpose of being able to do retries is that we want to arrange it so that your users can have a decent experience even when your application is misbehaving. But that does not mean that we want to mask that from the operators. The operators should still be able to look at the application and see how terrible it is. So in this case, Linkerd Viz will still show us, oh, hey, look, this is about an 80% success rate, and it's running at, 7-ish requests per second. Those are kind of the real numbers for what's really going on. If we want to see the effective numbers, we can use the Linkerd Viz routes command. Everything you can see in the dashboard there, you can also see from the command line. And I'm not really going to go too far into this, but this one in particular is really interesting. If I ask Viz routes to show me traffic, talk to me about stats for traffic going from the face deployment to the smiley deployment, and I'm going to ask it to do the wide output format, we will see the effective success rate, the effective requests per second, and we will also see the actual numbers. So in this particular case, we can see that we're actually only seeing 80% success, but once we factor in retries, we managed to get everything up to 100%. We can also see here that our effective request rate right now is about 6, but the actual one is over 7. And this points out a very important thing, which is that retries are not about protecting your workload. Retries are about providing a better user experience to the user of your workload, but they will actually increase traffic going to the workload itself. There's a question in the chat from Tobias. Sorry if I'm pronouncing your name wrong. What was the error you got that you tell Linkerd to retry on? By default, Linkerd will retry on, I believe it's any 4 or 5 XX HTTP request. I'm actually going to have to go look that up to be sure of that. But you can tune this in Linkerd. You can configure it to say only retry on these specific status codes. By default, it's pretty broad. And for most REST APIs, if they're well behaved, then, and most gRPC actually as well, you can just leave it as the default and it will behave in a reasonable way. But you can configure that if you need to. So yeah, retries, not about protecting your workload. Can one inspect the errors from Linkerd? Yes, one can. Let's come back to that one a little bit later because that is a little bit more involved to walk through. And I want to do timeouts as well. So the other thing that you may notice here is that, yes, we are getting green backgrounds and smiley faces, but we also have some of these completely empty cells. And what's happening here is that those are places where our terrible application is taking a really long time and the browser is just giving up. It's not getting an answer back in time. So it's just like, yeah, whatever. So we can also protect from that by adding timeouts. When we were doing retries, we kind of started close to the user and then worked our way down the call graph. That's not really all that important. And so for timeouts, we're going to start at the bottom of the call graph with the color service and the smiley service, and then work our way back towards the user. So we're going to make a very small change to the color service profile here. All we're going to do is just say, hey, we're going to add this timeout field, specifying that if it takes longer than 300 milliseconds, then we'll just go ahead and return an error to the user, or to the caller rather. And if we do this, what we should see here is some pink backgrounds starting to show up, but we should see them showing up more quickly. An important note here about timeouts is, much like retries, timeouts are also not about protecting your service. Timeouts are about arranging it so that the caller of your service has some agency and can decide what to do if things take too long. In our case, the face service, if it gets a timeout from the color service, substitutes a pink background so that we, the humans looking at this demo, can tell that a timeout happened. We can do the same thing for the smiley service, and the face service will show the smiley service timeout as a sleeping face rather than as the pink background. And if we do that, we should immediately start seeing some sleeping faces. Once again, we will have the things where We still have some of these that are just taking too long entirely because we haven't done anything with the face service itself, but we can already see that there are a lot fewer of them, and the other ones are happening a lot more quickly. All right. So for the face service, we approach it the same way, but what the demo does is different. In a lot of cases, when you're working with user-facing data, if you cannot get an update to your data, a reasonable thing to do is to just show the user the old data. Like imagine you're doing a weather application. If you can't get an updated forecast, you can probably show them the one from 2 or 3 minutes ago and it'll still be fine, right? So what we're going to do here with the face service is apply the same sort of timeout, but recognize that the GUI, rather than showing us a pink face or whatever, it will just continue showing us the same thing it got beforehand. And for the moment, it will also put up a little counter so that we can see how often it's happening. So as we do this, we immediately start seeing counters appear, but we should see things go away. We should see those 2 empty ones fill in. All right. I'm going to cheat a little bit and just reload the web page. Come on, you can do it. There we go. All right. Okay, so there we go. And it's important to notice also, if I come over here and I click this hide button, that's what the user would actually see. And even though our application is horrible and slow and fails a lot and takes a long time, that's not a bad user experience there. So we can actually use the service mesh all by itself without changing the application to mask a bunch of this stuff and give the user a reasonable experience. And, this is important if it's things like it's 8 p.m. on a Friday night and you've just gotten reports that horrible things are happening in your application. This is a way that you can give the user a reasonable experience while you then go through and let the developers sleep before coming back to fix the application. You do still need to fix the application. One of the questions we hear a lot is along the lines of, well, doesn't this make it easier to forget to fix the application? Yeah, it kind of can. And it is important when you're using service meshes that in addition to the technical stuff, it's important that you also have business processes in place so that you can leave a note for the developers when they wake up on Monday morning and come in so that they can actually fix this thing, for example, stuff like that. Unfortunately, the service mesh by itself cannot fix the business process side of the world. That one's kind of on y'all. So, Cedric, did you have any questions? Anything you wanted to add there immediately?
No.
Okay. Let me go back then and talk a little bit about this question where can one inspect the errors from Linkerd. And as I answer this, I'm going to skip ahead. Do I have metrics on when a Linkerd timeout was for all services to review? You mean in the sense, Tobias, do you mean like logs or something that you can look back in time? So in terms of being able to inspect the errors, let's dive into the face deployment for a moment. This will be particularly fun because I haven't, got to confess, I have not tried this with this particular demo in a little while, so it'll be fun to see what happens. A couple of things to notice here. First off, when we click into the specific deployment, we can see all the things that are talking to this deployment and all the things that it's talking to. And we also can see things like when Prometheus tries to talk to the face deployment, everything works great. But when emissary ingress tries to talk to it, everything does not work great. So we get to see where the error paths are in this graph as well, which can be kind of powerful all by itself. But we can also come down here and take a look at live calls. So we can see that the most frequent things that are happening here are emissary ingress makes a call with the cell path, and the face deployment makes a call to the color and smiley deployments with a path of /. These are happening a lot, and we get to see some latency numbers about this. But a very, very interesting thing we can do here is we can click on this little microscope. And when we do that, it fills in this tap request set for us, and we can click on Start. And now we get to see actual live traffic while it is happening. So we can click on, I believe it's this, sorry. We can click on this thing, and this will show us metadata about this particular request that happened while we were watching. So this was an HTTP get to / this particular one worked and got a 200. There isn't anything over here about gRPC because this is not a gRPC call. It took 155 microseconds, which is kind of cool. Yeah, and so we also get to see that the application is actually handing over this xfaces user header. So you can see a lot of interesting and useful things about an individual request. And I'm kind of wondering, hang on a second, let me stop this. There we go. Here's one that got us a 500. So if we come over here, then again, we get to see we got a 500 back, and we can go through and see that kind of stuff. So hopefully that answers your question, Luca. Great. Andreas, I believe that is I believe that the response classes is the right way to go through and define that stuff. It's definitely in the service profile. How can Linkerd be integrated into deployment processes for blue-green deployments? For that, you should come to the Service Mesh Academy on May 16th. Or you can go to, let me put this in the chat. If you go to buoyant.io/SMA, then you will see the ones that we did previously. And in particular, the one that we just did about a sneak peek of 2.13 shows Linkerd being used for a Canary deployment. We actually did Canary and AB deployments there. And depending on your exact definition of blue-green, then one of those will probably fit, I hope. I'm going to go ahead and mark some of these as answered so we don't miss them. Okay. Overhead of deploying Linkerd to a cluster. One of the things we kind of like about the sidecar model is that the resource requirements scale directly with application traffic for the particular workload of the application. So if you're doing something that doesn't take much traffic, then Linkerd's application requirements are very, very low, like small numbers of megabytes of memory. And Linkerd's latency, I don't actually have hard numbers on that right now. Linkerd is actually the fastest service mesh out there in terms of latency, though. We work pretty hard on that. So typically, our perspective on that is that if you're worried about Linkerd's latency in your cluster, we need to have a long conversation about whether you should be using Kubernetes or whether you should be using dedicated hardware or, things like that, because its latency is low enough that it's typically not a factor. Obviously, I am biased, but we have measured this stuff. I just don't have the numbers to hand. Cedric, were you about to say something?
No, just before we move over into general QA and end of demo time, I wanted to, so sorry for my blunder before. I actually could kind of show off how Linkerd is deployed to the cluster. So I just wanted to quickly query the audience. If that's something you're interested in, please give me a quick yes or a thumbs up if you want to see that really quick.
All right, we're getting yeses.
Super.
Why don't you go ahead and take over the share? And off we go.
Cool.
I got to confess, I was a little curious if you were going to demo that earlier, but you must have decided not to. So
I meant to.
Sorry for not poking you on that in the first place.
No worries. We'll get it figured
Certainly,
out.
I kind of want to see it. So
sure. All right. Can you see that stuff? Cool.
We can see it.
Basically, so what actually happened, as I wanted to show this, I didn't have Linkerd installed. I didn't have Linkerd CNI installed when Flynn actually started his demo, so I really quickly had to do the whole process in the back. And that shows you how, how
Thank you. I
resilient it
appreciate
actually
that.
can be. So I actually now have to go ahead and so this is the HAPA user interface I actually talked about. Really quick overview. That's our cluster Linkerd testing. It's OK to 3E. Now here is the apps part. I can click install apps, and then we have a bunch of catalogs. In our case, I'm still going to do the CR approach, but here I actually will go in, delete the control plane. So the Faces app should show some failing requests again, because this is going to remove any mesh. And then we can also go ahead and remove the CNI really quick. So that's as is for, I will leave Linkerd because it's useful to kind of show later on. All right.
I actually think the demo is going to keep running cleanly because the CNI in that app has already, they already have the proxies and they already have the network configuration done.
So even if Linkerd fails, you will actually get back into for
a little while.
Until stuff needs to restart.
What's going to happen? Well, first off, if you need to restart, you lose the mesh. But also, there's a more subtle thing going on here, which is that each workload has a workload identity certificate. And so even if you don't have to restart anything, in a fairly short period of time, the identity certificate will expire and we won't be able to get a new one and everything will break. So don't do this in production. Deleting Linkerd and then expecting your apps to be happy, just don't do that.
Cluster is called Linkerd test for a reason. All right. So I quickly wanted to go in and show off one of those CRs, app CRs we actually talked about. So let's check it out. So this is the app CR for Linkerd CNI, application giants for IO. It's kind of app, and then so this is now on the management cluster. Left is management cluster, right is the workload cluster. Let's quickly go through it. It will install a Linkerd 2 CNI. It will be in the namespace. As I mentioned before, workload cluster is represented as a namespace. Specification, it's from the catalog giant swarm. It is named Linkerd. Its namespace on the actual workload cluster is Linkerd CNI. And here we can specify additional annotations to the namespace. So to deploy Linkerd CNI, it's recommended or required to actually not have it injected with Linkerd itself. So it's disabled on the namespace. And we also add labels, CNI resource true, and admission webhook disabled. So this is chart version or app version 10. Right, now let's list our resources. So if we check apps, we can actually see here is only Linkerd this and everything that's deployed with any Kubernetes giant swarm cluster. So these are just kind of the bare bones, except for Linkerd Viz. That's managed through the app platform. So as you can see, we also manage our own app, our own deployments and our own workloads through the app platform. Now let's kubectl apply -f and then the Linkerd CNI YAML. So this applied the app. Now let's get all resources again. We can see now there is an app called Linkerd 2 CNI running for 5 seconds. Let's switch over to the workload cluster. Here, as mentioned, it's represented as a chart. Those are typically in the namespace giant swarm. So let's list our charts. And here we can also see the chart Linkerd 2 CNI was just installed 30 seconds ago. Cool. Now that's deployed. We can actually check for namespaces and go to Linkerd CNI and see that the workloads are now running. So next we need to deploy Linkerd itself. That's located in here. Oof. So again, this is just app resource. Also, as I mentioned before, the secret, which contains, in this case, the certificate. I won't go through that again. We can just do kubectl apply -f linkerd. Same spiel again. Go to namespaces, giant swarm. Actually list the charts. And we have Linkerd running. Go to namespaces, Linkerd. And there we see that everything is trying to come up or coming up as expected. Everything is running. And that was basically it. Now, emissary. Let's do services. Okay. Oop.
You should be able to refer to that also as gremlin.demo.59s.io.
Sorry, 5?
59s. Sorry, number 5, number 9, s.io.
Cool.
Yep.
Yeah. So, yeah, we saw this before. Basically, everything is running again. Linkerd actually is tapped in, and it can show stuff.
Nice.
Cool.
Yeah, everybody almost got a much more interesting demo there. When it would have been very entertaining to go through and do the Linkerd mesh and go, wait, what's going on here?
Cool. Now that was my part of the demo. Thanks for sticking with me. Sorry for the blunder again, but that was really fun.